Hey guys, welcome back. So we are now in section 4.4, ASA and AAS. So if we take a look, ASA means the side is included and AAS means the side is not included. So that's the difference between the two. So taking a look at our example, it says, show that the triangles are congruent. So reading off our evidence, that we've got an angle, a side, and an angle, and it's matching this angle, this side, and this angle. So that's why they concluded, yes, this is congruent because of angle, side, angle. Now it's saying state whether they're congruent based on these four choices, or if I can't get it, I just have to say no, not enough information. So I notice here they have a purple side matches a purple side, a red side matches a red side, and this third side matches. So that would spell side, side, side. Now when we take a look here, we have an angle matches an angle matches another angle, and a side matches a side. So if I color code them, it might be easier to see that my evidence spells angle, angle, side, angle, angle, side. So that's non-included side. So I'm going to write angle, angle, side. Okay, 17 states are two triangles with two pairs of congruent angles and one pair of congruent sides. So two pairs of angles and one pair of sides, always congruent. So let's see. Let's see if the order even matters. So if we have two angles and a side, we could have this, right? We could have this, which also would be congruent. So I'm going to say yes. That's always congruent, unless, I'm going to give a little caveat. Unless one triangle says Asa and the other says like angle, angle, side. They both have to say the same thing. Both must have the evidence in the exact same order because they're twins. Okay, looking at 18, it says make sense and persevere. So this is an angle, right? And that matches this angle. This is an angle and it matches this angle. And we have a side and that matches this side. So our evidence spells angle, angle, side. So we're going to say yes because angle, angle, side, triangle congruence. Okay, so 4.5 is talking about congruence in right triangles. So when we look here, we have an angle matches an angle, a side matches a side, and another side matches another side. So that kind of looks like Ass. So I would originally kind of not like that. However, this is a right triangle. So I technically would call this the hypotenuse, and this also would be called the hypotenuse. So the hypotenuses match. Additionally, this short leg matches the short leg. So technically, this would spell HL. Now let's take a look at 19. It says this side is 2 lengths long. This side's 2 lengths long. That's my hypotenuse. So that's pretty good. And then this side matches this side. So you're thinking, I'm not sure. So let me think about this for a minute. If I called this segment AB, then this side of the triangle is the length of side 1 plus segment AB. And then if I look at this triangle, this side is also equal to side 1 plus AB. So that is technically, both sides of that triangle are equal, and those are legs. Right? And my hypotenuses were equal. That was given. And so this I'm going to have to say is 8L. HL, right triangle congruence. Okay. So communicate precisely. Triangle ABC is an isosceles triangle. Okay. ABC is an isosceles triangle with a vertex bisected by a line segment. Okay, so bisected by a line segment. Draw the triangle and prove the resulting triangles are congruent. Okay, I'm going to make this a little bit bigger so it's a little bit easier. Okay, so this is there. Okay. And so they're saying this is an isosceles, so that's given. And we know the isosceles theorem states if these two are equal, then these angles are equal. Correct? And then we know using the isosceles theorem that if you cut this in half, these two angles would be equal. And we also know this side is equal. So we can kind of think of this as side, angle, side, or angle, angle, side. Either way, these triangles are congruent. We also know if we cut an isosceles triangle in half, that would be 90, that would be 90. So again, I would take angle, angle, side, or angle, side, angle, maybe even angle, side, angle. Nice. Okay. So last one, lesson 4.6. We talked about any of these criteria would work. And so 4.6 makes it harder by overlapping. So as a technique, we simply separate the two and copy over the information provided. So looking here, it's saying, given rectangle ABC, how do you go about proving angle ADB? So ADB, this angle, how do you prove this angle matches this angle? Well, you just go through step by step. So in a proof, we know that it's a rectangle, so opposite sides of a rectangle are congruent, and so I can kind of see this triangle, right? And I can see this triangle. And moved it over there. All right, so we know these sides are congruent. We know they share a right angle, right? And as we broke this up, right? Oh, wait, I wanted to copy this triangle because I'm trying to prove that this angle is incongruent to this angle. So I'm trying to focus on those, yeah. So I know these are equal. I know both of these are a right angle, right? And AB matches AB. Yeah, they share the bottom of this. So that's this evidence spells side angle side, side angle side. Yeah, so this works great. Those are congruent. And then using CPCTC, if they are incongruent because of SAS, then this angle would match that angle. And you've proven what you've been asked to prove. Nice work. So as we look at question 21, let's think about this for a minute. This is 3x, and this is x, which is 3x. So if I look at the first triangle, right, I know that's 3x. And if I look at the second triangle, I know that's 3x. So those sides match, right? I know that's 90 and that's 90, so that's fine. And I have this angle here at the top. And so this is yes because of angle, angle, side, angle, angle, side. The side that we know about is not trapped between the two. Ooh, funky. This is kind of an interesting pattern. Okay, so this triangle, right? And then this triangle, right? Okay, so this part has 2 marks on it, right? This part has 2 marks on it, so that's equal. This angle down here matches this angle down there, so those match. And then I'm not sure, but if I zoom in, I think I can prove another part of this. If I actually look at these triangles, right, those are actually congruent because the vertical, So I actually know that this triangle, the orange one, is congruent to that one because of angle, angle, side, right? Angle, angle, side, angle, angle, side. And now that I know that, I actually know that their corresponding sides are congruent. So that means I actually know this third side corresponds with this third side. And this fourth side corresponds with this fourth side. And so now I can go back to thinking that this big length right here is side 1 plus side 4 plus side 3. And this is side 1 plus side 4 plus side 3. So technically, I could put 5 tick marks on this. A fifth length is congruent, and that spells SAS. 23. It says, describe where to place point E along line AC. So where can I put point E along AC such that triangle ABD is congruent to CBE. Okay, so if D was straight down, then I would put E straight down in the middle, but it's not. So here we go. If I'm looking at this, then for where would I need to put E? So it looks like I just need to flip it over. So E would have to be placed somewhere right about there. Is that kind of making sense? And so then explain why those would be congruent. Okay, so I'd have to place E there, and my reasoning is this triangle, ABD, would be congruent to the red triangle, BCE. And I know that angle A and C match. I actually know this length, ED, is ED, and so I would need these to match. So that's where I would end up placing it, as I would place it the distance between AE to match DE, because then this bottom would be side 1 plus segment ED, and this would also be side 1 plus segment ED. So that would work, right? And then you actually know that since these two base angles are equal, these sides are equal. So these sides are equal to these sides. And so this evidence spells SAS, side, angle, side. Cool, side, angle, side. Thanks for joining us, guys. Take care.